Hello, and welcome to Navigating Cloud Cost Management in Kubernetes Environments. Today's webinar is sponsored by Harness and produced by Actual Tech Media. My name is Scott Becker. I'm from Actual Tech, and I am excited to be your moderator for this special event. Now, before we get to today's demo-packed session, we have 4 housekeeping items that are going to help you get the most out of this session. First off, we want this to be an informative session for you, so we encourage any questions in the questions box in your webinar control panel. Not only will we have team members responding to questions during the live event, but we'll also have a dedicated Q&A session at the end of the session where we'll discuss in greater detail some of the top questions that you ask. That Q&A panel is also the place to let us know if you have any technical issues. A browser refresh will fix most audio, video, or slide advancement issues, but if that doesn't work, just let us know in the Q&A and we'll provide further technical assistance. Now, second, in the handout section, we've got a few resources there. I'd especially like to call your attention to a link to get started with Harness. There are also some links labeled ATM, which stands for Actual Tech Media, that you can check out in there as well. So I encourage you to access those resources now and share them with your friends and colleagues. Now, third, at the end of this webinar event, we will be awarding a $250 Amazon gift card to one lucky registrant. Of course, you must be in attendance during the live event to qualify for the prize. Official terms and conditions of that prize drawing can be found in the handout section as well. Just scroll to the bottom and you'll find all the details there. Okay, finally, one of the best benefits of this event is the opportunity to ask a question of our expert presenter. So to help encourage those questions, we have a special additional prize for you. That's another Amazon gift card, this one for $50 for the best question. After the event is over, we'll look at all the questions that came in, pick out the very best one, and contact that prize winner. All right, with that housekeeping out of the way, let's get to today's fantastic content. So it's my pleasure to introduce you to our presenter today. We have Robin Elliott, who's a principal sales engineer at Harness. Robin, welcome.
Thank you. Happy to be here, Scott.
Yeah, well, thanks for being here. Take it away.
Okay, we will get going. Just confirming, Scott, that I am now in presentation mode.
You are. I can see it.
Thank you very much. Well, thank you, everyone, for attending today. Hopefully, we're going to make this an interactive session towards the end. Going to be a combination of some slides here, as well as some interactive demos in the Harness solution Cloud Cost Management. Agenda for today is a quick recap of our understanding of where Kubernetes is today and a lot of the problems and where people are trying to get to. We've got a breakdown of our sort of feature functionality and how we tackle that problem, sort of based on the maturity of the FinOps type paradigm. So we're going to cover showback, we're going to get into chargeback, and then we're going to talk about how can we optimize and operate efficiently. So I'm just going to build this slide out. If we look at the types of problems that people have today, top left, current state, a lot of people are experiencing poor visibility into their Kubernetes, whether or not it's on-prem or in the cloud. An inability to attribute those costs towards business units, teams, software products that they may be delivering. Optimization issues, just not being able to understand, where are you over-provisioned, where do you have idle resources sitting. How to remediate idle cloud resources as well. And then lastly, if your costs are increasing, how are we planning on trying to control them? If we don't have visibility and an understanding of who owns what, how can we understand who do we need to approach when we're trying to optimize? So a future state is we want to be able to identify and remediate, excessive cloud spend. We want to be able to actually do showback and chargeback. So that individual teams, product owners understand what is the cost that's associated with their activity. We want granular visibility, so we want to be able to see this across clouds potentially if you're multi-cloud, both environments like dev, QA, pre-prod, prod, as well as teams. We want to be able to forecast where spend's actually going to go. So is it increasing? Where's it trending to? And we want to foster a culture of collaboration. So this isn't a finance problem. It isn't a DevOps problem. It's a combined issue. Yeah. So unless you treat it as such and get collaboration going between whoever owns like FinOps and the development org, you're not going to get far there either. Down the bottom, we've got some required capabilities. So obviously, we need a real-time, comprehensive visibility into our Kubernetes environment. We want to make sure that we can compare costs across internal teams that are using our Kubernetes infrastructure, as well as the software products or capabilities that they're producing. We want to be able to be informed. Like, we don't want to, rely on people having to go check, online screens to understand that there are sudden cost anomalies or increases in our spend. So getting alerting on those. We also want to be able to ensure that when we interact with developers, they pay attention. Okay, so one of the biggest problems is trying to get people in a development org where they've got different priorities, like getting the next version of the product out, to actually pay attention to optimizations that they could be doing to save costs. And then lastly, a somewhat unique component towards the harness-based solution is turning off idle workflows. So if you've actually got workflows running in your clusters in lower environments, let's say, that are not actively being used, why are they sitting there consuming resources in the cluster? So, lastly, introducing Spot, or in a Google terms, preemptible compute instances into your Kubernetes node pools. But a lot of people don't use Spot today because of the risk of interruption, so we'll cover a little bit on how we can mitigate that risk. Harness platform is built to optimize the cloud costs. Starting at the right. That's what we're going to be reviewing today. But we are a platform that does tackle some of the key issues that development operations and the SDLC is experiencing in today's world. So part of our other activities are accelerating innovation through DevOps modernization, improving the developer experience so that they're happier and you don't have a retention problem. And also we have modules around secure software delivery, which is pretty paramount today. Real quick, like I said before, we're going to be covering cloud cost management today. It was the second product that Harness brought to market after continuous delivery on the left-hand side. We have been around since 2017. We've got over 600 enterprise customers, $450 million of venture-backed capital, and approximately 800 employees today. So let's get into the meat of it, and we're going to start with the concepts of showback. In FinOps terms, this falls under inform and visibility. So the concept of we want to understand, where are our Kubernetes costs in relation to our cloud environments? How can we monitor these for increases, decreases, and be able to easily allocate these costs with or without perfect tagging in the environment? Everyone seems to think that you need perfect tagging. Most people don't, so we'll discuss that a little bit later. So specifically to Kubernetes, we do want deep visibility into our clusters. What we're looking at here is a view that's showing all the clusters in my environment. We've got it in a graphical form. You can see that recently my costs have increased dramatically. I did that on purpose for this demo that we're about to do. Down below, you can actually see the individual clusters. We've got columns representing their total cost, how they're trending. So we can specifically see the CCM demo line on the second has gone up 20% so far. And we have something called the efficiency score. We're going to talk about the efficiency score in just a little bit, but it's a way that we can measure, how are we actually utilizing the spend? Okay, so in short, right now, it's made up of both idle and unallocated cost within the cluster, and that determines the efficiency score. It's out of 100, and as you get close to 100, it's better. Second capability that we want, which I talked about a little bit earlier, is anomaly detection. So no one wants to be coming into these screens and monitoring them on a regular basis, okay? So you want an automated process where if cost increases are seen day to day, we actually get notified about them. So here's an example, like I mentioned before, of my CCM demo cluster that I recently increased in size, added more compute for it. And we can see that we've got two anomalies as it grew the first day and then the second day as well. You can tie alerting to these so that you can get notified via Slack, email, Teams, etc. So I mentioned efficiency, how we score each of the clusters. Efficiency is a sort of somewhat unique metric that Harness came up with. It's based on a score out of 100. And what we want to see to get a perfect score is we want to see 65% of the resources that you're spending money on, as in the compute in the cluster, actively being used. Okay. We then allocate 30% for the varying workloads throughout the day. Okay, as you may have those scale horizontally or vertically. And then we also allow a 5% buffer for net new workloads. So that's how the score is broken down. Where you actually fall on the score is indicative of how efficiently you are using your spend on compute. Green, healthy, is going to be you're in the 61 and above range. Orange is obviously room for improvement, 31 to 60. And red is poor. Essentially, it means you're sort of throwing a lot of money out of the door or into Jeff Bezos' hands or whichever cloud vendor that you have. We'll look at that in a little bit more detail when we get into the demo. We also want to be able to have deep visibility. So we've looked at like the cluster level. We can look at it from a node level, but we can also look at it from an individual workload level. What we're looking at here is an example of a node. Okay, so this is a view where we're looking at a node within a cluster. Down below, we can actually see all the workloads that were run on it, how much memory and CPU they requested, how much did it cost you, and how much of that cost was idle. Okay, and then above, you can actually see a pictorial of sort of how bad the potential situation is. Okay, so the red line is indicative of what's called the requested CPU and memory. That's what the developer essentially reserved when they deployed their workloads. And then the blue line down below is actually showing you the real world usage. And that delta between the two is that cost that we're trying to reduce. Okay, we're trying to make sure that we set that red line. So it's, as close to the blue line as possible, but with a buffer in place to avoid risk. When we're talking about showback, and obviously you want to have definitions within the system so that you can have views that are associated with teams, with environments, with costs. You want to make sure that those are easy to maintain. Okay, so most organizations have change. Teams might, new teams might start up. Teams might get moved underneath VPs. So it's always good to have a single central place where you can define what we refer to as cost categories. Okay, so in this example here, I've actually got 3 cost categories that are divvying up the cost of my Kubernetes environment. We've got development, QA, and production. And the production view is expanded, so we can see a couple of things here. It's including costs where there's a tag or a label, environment ID, which has any of these values for production. So this is an example of where you can handle some of that bad tagging, okay, where people have done different capitalizations. Maybe they put a 0 in instead of an O, etc. Okay, so if you look at our production definition here, it's pulling in a version set of different product values for the environment. As well as down below, it's actually pulling in additional data from another cluster with some different labels as well. Okay. Nice things about cost categories, like I said, one place to define them, then you can reuse them throughout the system. And they also allow you to share costs. So if I was to continue through this wizard that we're looking at here, I could actually define shared costs that I want to share across each of these buckets that I've defined. And then lastly, for showback, we don't just have like interactive perspectives that you can slice and dice. We also have dashboards available. Obviously, people expect dashboards today. We do ship out-of-the-box dashboards with the system, but we also allow you to clone those or create your own from scratch. It's not in the text here, but the dashboarding solution we include in the product is actually Looker, which is part of Google's GCP data analytics suite. So it's a full-blown enterprise-grade dashboard solution that you get part and parcel as part of the product. Second dashboard example, this one's slightly more technical. This is where we're looking at the details behind a specific cluster. We can track its efficiency score over time with a heat map at the top, so you can actually see where I've made the cluster more efficient, specifically for this session. So it started going orange and red as far as the last few days. We've also got, what namespace efficiency is out there. So we can see quite a few namespaces are in red. We've got workload efficiency, so we can see individual workloads and how performant they are. And then down below, we even get into CPU, memory utilization, averages, maximums, etc. So a lot of detailed information. So what I'm going to do now is switch into the product real quick. And let's just have a look at that section that we've covered. So this is the Harness CCM-based solution. As I mentioned before, it is part of a larger platform, so we can see some other icons for other modules on the left-hand side. But we're going to start off going into perspectives. A couple of things to note here is you can group perspectives. This is not only for ease of use, but it's also for security. You can tie specific users and teams down to specific folders, so they can only see what they need to see. Here's an example of that view we were looking at before, which shows me all my Kubernetes clusters. So if we look at the CCM demo cluster, which I inflatedly increased in size recently, you can see its cost trend has gone up by 19.14%. It's got a pretty low efficiency score, and that efficiency score is made up of looking at the total cost together with the unallocated cost. The unallocated cost is essentially the compute within that platform we're paying for that we're not even touching. Okay, nothing is deployed to use that unallocated cost. And then the idle cost here is more so the responsibility of the developer. This is where, when they've deployed a workload, they've requested too much horsepower. Okay, so idle cost is the role of the developer. Unallocated cost is the role of the cluster administrator to essentially watch and make sure that that cluster is not oversized. If we move on, we talked about being able to have different views in here. So you can see there's a whole different aspect of views I can go into. I can actually look at the nodes here, pull up our node view. I can filter, so I can specifically say, hey, I'm interested in the cluster name CCM demo. I can group by other aspects. Okay, I'm just going to stick in here for a second. So we can see all the clusters, the compute that make up this cluster. We can actually go into one of these. And like I mentioned before, we can see its utilization. So this is a pretty large, beefy box, 16 CPUs, 64 gig of memory. We can see what's currently being reserved on it, up to about 12 and a half CPUs. And from a memory perspective, 51 gig. Okay, and then down below, we've actually got the details of the individual workloads. The big problem here is that delta between the blue and the red line. Like I said, this is a manufactured example that we're looking at here, where I've deployed quite a lot of stuff, nobody's using it. Therefore, the CPU and the memory actual usage is pretty low here. Okay, But in reality, you will see large deltas in your environments between what a developer thinks is needed and then what's actually being used. This problem can be especially paramount in lower environments if your development organization does not have the discipline or the capability to make these sizing decisions based on environment, as in to request less resource in prod and QA, more resource in a pre-prod environment, and then obviously size it appropriately for production. So if you're not sizing by environment, this is where you can get large deltas and a lot of wasted cost. Lastly, let's just go in and look at that cost category real quick that we had a screenshot of. So here is my K8 environments. Here are my cost categories. Here was the production one. I can edit this. If I wanted to add a new cost bucket, I could. Maybe we've got a pre-prod environment, okay? And here is where I can come into my cluster. I can pick, build a query saying this cluster, these namespaces, these labels, even all the way down to specific workloads if I need to, okay? So remember, cost category is single place to make these types of definitions. I've got some other examples in here. For example, we've got some of the harness product modules here. That might be another way that we want to slice and dice our costs. But you might, want to view costs more traditionally, let's say by departments within your organization. Last area I want to talk about, we did talk about dashboards a little bit. So let's just have a look at the cluster dashboard. We can see at the top, we've got the ability to filter in on specific clusters, namespaces, etc. But we've got all sorts of different visualizations here. So this first one is actually giving us that breakdown of, how much unallocated cost do I have where the cluster's oversized? How much idle cost do I have because the developers have asked for too much resource for their workloads, etc. How are my costs trending, comparing it 60 days ago to 30 days ago? These are all capabilities that you can build within dashboards. Like I said, we give you a bunch of examples out of the box. This one here is, once again, it's looking at my total cluster spend, looking at that idle, unallocated, etc., and my efficiency score overlaid. So you can see I've recently added a bunch of inefficiency, so my total costs have gone up here, and my efficiency score has dropped. So this is how you can track improvements over time. You can actually have these dashboards where you're gamifying them, comparing different teams, so that they can see, are they better than their peers from an efficiency perspective? Lots of different ways and things that you can do within dashboards. And if I was to show you one quick thing, like I mentioned, you can create these yourselves. We actually have an AI digital assistant that can aid you in creating these. But also just to show you what under the covers this looks like. We essentially give you the data view on the left-hand side here, where you have a number of fields that you can pick from, okay? You have a whole bunch of different visualization techniques that you can choose from. So you combine selecting the data that you want on the right with the visualization you want in the middle. We have a couple of filters here, okay? Where we can define, default times, what type of cluster type are we looking at? I know this is a Kubernetes session. We also do ECS as well, by the way. So a lot of the stuff I'm talking to you about Kubernetes would also apply to our ECS capabilities. So hopefully that's given you a brief look at, different visual capabilities of how you can get into the meat of the data, but also track it at a higher level. Okay, so coming back to our presentation, going back into slideshow mode, we're now going to move on into the topic of, great, I've got my visibility. So how do I, present it to people? How do I make them responsible and sort of mature and start getting out of that crawl stage of FinOps and into more of, the walk, okay? So we're talking about inform and allocation here, which is essentially the introduction of budgets. Now, a lot of organizations, as they mature into budgets, it shouldn't be something that people get scared of. It's a bit like a comment from Pirates of the Caribbean with the Pirates Code. It's a loose set of rules. Okay, so you can mature into budgets, essentially saying, look, we're going to set you some goals. Please try and achieve them, but you're not going to be held accountable. As opposed to saying, hey, here's your budget, you will be held accountable to it. So how you actually choose to implement these in your org, and what are the consequences for exceeding your budget? That's up to you. Okay, but like I said, what we're trying to do here is to progress from just show back into charge back. We want to make sure that, we can use those cost categories, that single place definition of where you can define what a team's cost is, what a product cost is, etc. We want to be able to base those budgets on top of those definitions so that we don't have to redefine our costs again. When you get into budgeting, there's lots of different ways to look at it. So we want to make sure that, we can do it over multiple time periods. There are some people that even do daily budgets, but you can do weekly, monthly, quarterly, annually. We have a budget that allows you to actually set individual budgets for the month, for the whole year. You also probably want the capability, as you mature into this, of rolling up budgets. So if you have a VP that has 10 teams reporting to him, and all 10 teams have their own budget, wouldn't it be nice if you can just combine all of those and then show the VP, hey, here's the rolled up budget. So we can support that as well. Here's an example of looking at a budget for a data science team. We can see immediately top left what their current spend is in the month. So currently they spent like 51K. Their budget amount is 71K, but they're already forecasted to exceed their budget. So we're forecasting they're going to land at 76K at the end of the month, which is 106% over budget. If you look at the alerts next to it in the middle of the top of the screen, you can see that someone's already set up some alert patterns here. You can do this against email, Teams, Slack, etc. So we can see there's an alert out there for forecasted cost exceeding 105. So whenever within the month we determined that we were going to exceed that 105, we would have sent that notification out. Down below, you can sort of see the visual representation of costs over recent months. Together on the right-hand side, where the mid shade blue actually shows the spend to date within the month, and then the lightest blue is the forecasted cost of what's remaining in the month. And you can see that we're above the budget line. Okay. So this particular section is a little bit short, but we're going to switch back and just show you this live in the product. So here's my budget screen. If I was to go, it's that data center budget. We can actually see, since I took that screenshot the other day, a couple of things have changed, and we're now forecasted to land at 103%. Like I mentioned before, we've got our alerting available here, our visualization down the bottom. And if I was to go into edit mode here, you can see we've got a wizard experience where we can come through. Notice the budget period at the top here, which currently says monthly. That would be where you could select those other time periods that I mentioned before. We have different budget types. So this is a specified amount, what would be referred to as a fixed budget. One of my colleagues has gone in here and put a ridiculous growth rate in. I don't think anyone would like to see a monthly budget with a 10% growth rate. But yeah, you can actually put things in like growth rates. You can say, hey, month over month, I am expecting this to increase. Maybe, I'm delivering a new service and I expect its usage to ramp up. And so I do expect costs within this budget to go up 2% month over month. So you can do things like that. And then here's where you can do some of that notification. So we've got some examples here of sending some emails out and hitting a Slack channel based on, let's say the forecasted cost exceeding 105%, then we'll send a notification to a Slack channel. So that's what a default budget looks like. If we want to just have a quick look at what a rolled up budget looks like, here's an example where we've got a couple of Harness product modules, continuous delivery, feature flags, and continuous integration. Each of them has their own budget, but we've rolled them up into a budget group. Okay, so this is just another capability that we have within the product. So like I said, budgets set goals. Whether how you hold people accountable to them is a company and a personal choice. Okay, but we have the capability within the product where you can do a lot of fun things here. You'll also notice if I just came back in within the perspective, let's say for the data science team, that we do have quick links at the top of the perspective here. So not only are we showing like total cost and how it trends, but they've got a quick link so they can see their budget, where they're forecasted to go, and then also a quick link to recommendations around the spend that we're seeing here. I'm going to now switch into that section in the presentation. So we're going to move on. So optimization. So how can we optimize our clusters and workloads for peak efficiency? Okay, so this is a combined problem. You have the cluster administrators. They sort of own the cluster definition and the compute. And then you have the developers that are deploying to that cluster. Okay, so two roles and personas that we're trying to work with here. So Harness does generate recommendations around Kubernetes. We also support a ticketing workflow, both with Jira and ServiceNow. This can potentially help increasing in your adoption. You might even use the word enforcing. The FinOps org does surveys every year. For the last 2 years, one of the biggest problems out there is, trying to get people to pay attention to recommendations. Everyone in IT has information overload. Like I mentioned before, developers have other priorities normally, trying to get product out, etc. They're not too bothered about trying to save money unless they've got time to. So if you have a sort of ticketing flow where you implement SLAs, that's one way of communicating a recommendation to a user and making sure that at least they respond to the ticket, read it, and see the details of the recommendation instead of like having a rule in their email to move the recommendation into like the bit bucket. We can track current open implementations as well as applied implementations. So you can track, what have you actually implemented out of your recommendations and how much money have you saved. We do recommendations, like I said, both for node pool and workloads. And just remember that efficiency score. Idle cost is the developer's responsibility. That's where they've requested too much resource. And then unallocated cost is the unallocated parts of the cluster that aren't even being used, and that's the administrator's responsibility. So what we're looking at now is an example of a cluster-based recommendation. So most people today, there are exceptions, but most people today are running clusters based on node pools. A node pool is essentially a definition of the compute, like the VMs that underpin the cluster. I'm making no assumptions about the knowledge base on Kubernetes on this call, so I apologize if you're a big Kubernetes administrator. I may be covering stuff you already know. But we generate these recommendations based on all the metrics that we're collecting, okay? And so we can see here, if we look at this example, we have our current configuration on the left-hand side. So we've got a node pool of 4 compute instances. They're pretty beefy. Each has 16 CPUs and 64 gig of memory. And that comes with a cost. Yeah. So currently we're paying approximately $2,237 a month. On the very right-hand side, under the tune recommendations in the blue box, we've actually got, well, here's what we're really using. Here's the high watermark. And we allow you to pick different time periods of usage. You can say last 7 days, last 30 days, 60 days, 90 days. Okay. What was my high water mark? Okay. And that tells us, well, how many CPUs were used as a maximum? How much memory was used as a maximum? What is the largest workload that I saw? Okay. These are all factors that help us determine a recommendation. You need to shift to this instance family, these sizes. We can talk through this one a little bit. A couple of things I want to point out. Firstly, when you look at the preferred resource needs, the CPU and the RAM box, the CPU says 10 CPUs approximately. The RAM says 12 gig approximately. There's a ratio there. That's a very close ratio between CPU and RAM, okay? If you look at our original instance types, there was a 1-to-4 ratio between CPU and memory. I mean, that meant that based on the workloads being deployed here, we were always going to be wasting a ton of memory with a 1-to-4 ratio when our workloads are closer to 1-to-1. Now, most cloud vendors, and I'm not going to call myself an expert on every instance family, but I'm not too sure anyone does a 1-to-1 instance family between CPU and memory. Most of the time, it is a 1-to-2 is the lowest you can go. So you can see in our recommendation here, we're recommending that ratio of 1-to-2 from CPU to memory. That's the first thing. The second thing we're doing is we're only including enough nodes to handle that high watermark, plus any buffer that the user wants to set. So that buffer is a sliding buffer on the middle of the screen on the right-hand side. So you can de-risk this. You can say, hey, I anticipate that my workload is going to increase 20%. I want to account for that now. So you can slide that buffer 10%, 20%, whatever you want. And we'll adjust the recommendation, okay? And then the recommendation tells us, well, how much are we going to potentially save if we accept this new configuration? And you can move on, okay? So applying a node pool recommendation, it's not rocket science, but it's also something that I feel would be quite difficult to automate. So within the product today, we do not automate applying a node pool recommendation. I am not a cluster admin. I've been in a sort of sales solutions architect role for a number of years, too many to count. You can look up my LinkedIn profile if you want to. I have resized node pools on all cloud vendors. It usually takes anywhere from 30 minutes, maybe an hour, okay, to resize a node pool. So what I'm trying to say here is not rocket science. Even if you do it manually, it doesn't take that long. Generally speaking, in lower environments, it's something safe to do without any downtime, okay? There are exceptions. There are certain specific parts of Kubernetes, things like affinity rules, where someone may have actually referenced node pool names that can make this a little bit more complex. But in general speaking, 80+% of the time, resizing a node pool is a 30-minute to 1 hour effort. There's documentation out on this. Giving you an example here, nice documentation on how to do it on Azure. In this article, explains the high-level steps. Create a new node pool with the desired SKU based on the recommendation. Cordon the existing nodes, which means say don't put any new workloads on my existing node pool. You then drain the existing node pool. Kubernetes takes care then of shifting all the workloads on those nodes into the new node pool. And once that's done, you can delete the original existing node pool. Okay. Not rocket science, great way of saving money. In my experience, and I've been doing this for over 3 years now with 100+ customers, resizing node pools is usually one of the pieces of low-hanging fruit where you can get a lot of savings month to month. Second type of recommendation is a workload recommendation. So that first recommendation we just looked at is like the administrator of the cluster. Here, we're talking about developers, okay? So what we've got here is an example of a workload, Flux. Yeah, it's a Flux Argo agent for anyone that knows GitOps on the call. On the left-hand side in red, are the request CPU and memory sizes. I'm not going to get into the specifics of the limits right now, but just understand that request setting of 1 CPU and a quarter of a gig of memory, that's essentially reserving that. It's saying, I need that. That's what we're going to pay for. Okay. Down below, we've got some histograms that actually track over time where the CPU really fell and where the memory utilization really fell. Okay. And so we can come up with a recommendation saying, well, based on actual real usage patterns that we've seen over the last 30 days, and then you'll notice we've still got that same buffer on the right-hand side that I've set to 10%. Okay, it comes up with a new recommendation. Now, this new recommendation is actually saying, memory wasn't that bad, okay, but you were really over-allocated on the CPU. Yeah, this is in a dev environment. There's very limited activity on this FluxArgo agent workload. It doesn't need a whole CPU. You can give it a fraction of a CPU. That's the other thing to note here if there's more FinOps financial people on the call. Kubernetes is good in that respect. When you're talking lower environments, you can do fractions of CPUs. Okay, you don't have to think in halves or anything like that. So just another example of a recommendation. Depending on who you are and the type of workload, you might be looking at small savings here. In all honesty, sometimes the savings are not that great, and is it worthwhile having a developer address this? And I'm going to talk about that a little bit more in the second slide. But you can be the type of company. We have companies that do web-based media broadcasting. They've got a TV guide. Where one instance, which is 2 CPUs and 8 gig of memory, supports X thousand users, but, they've got millions of people, so they're going to have like this scenario here. The savings are going to be a lot more potential savings, and they've got 300 of those deployed at any point in time. Okay. So a lot of the times when you're talking about the workload recommendations, it is a question of, well, how much is it oversized? And how many instances do I have? It's going to drive what are the potential cost savings. Here's just another example of the detailed information we give to the developer. So when you give a recommendation to a developer, you're potentially questioning something that they thought about before, hopefully, when they came up with the original settings. So we don't just want to give them a recommendation that they have no confidence in. Okay, we want to give them detailed views of the data, okay, where they can actually see the problem. So once again, if we look at the right-hand side on the CPU, it's essentially the delta between the blue line and the red line, okay? That's what we're trying to get the developer to address. And if you may ask, why has this red line got some humps in it? That's just some regular deployment activity that was probably occurring against this FluxArgo agent, where we had the old version and the new version deployed at the same time. Okay, so how do we engage with developers and make this easy for them? One way is, if you tell a developer, hey, look, here's all the data, I've shown you all the graphs, we think you should change this memory setting. For them to actually change that, normally they're actually going to have to go, back to their source code management system, check out a file, make a change to it, do a deployment, and then test to see if, anything breaks, right? We have a way of automating that with Kubernetes recommendations. So as part of our solution, like I mentioned, we are a larger platform. We do the full SDLC with other modules, but that means that we have a pipeline engine. And we actually make that available to do things like what we're looking at here from a cloud cost management perspective. So this is an example run where we basically ran a pipeline that said, hey, for this cluster and this namespace, go find any recommendations that are out there for workloads and apply them. Okay. So what we're doing here is we're actually dynamically on the fly applying it. We've got an example of what that looks like. On the right-hand side, we've got a container, a resource name, and we're essentially in that P100 little output value. That's what we set like the CPU and the memory request and limits to. So we've done the legwork, okay? So you can set it up where you take these recommendations in a lower environment like dev or QA, and we can automate applying the recommendations on a temporary basis. And then just get to the testing phase. Then say, hey, developer, did anything break? Run your QA tests. Is everything looking good? Great. Now we know that we validated these recommendations. Let's actually go and make that change for real. Okay. So just a technique where you can enhance adoption by taking some of that toil and effort out of looking at these recommendations. Okay. Another dashboard view, just to say, recommendations, you can include them in dashboards. You can filter these where teams, only see their recommendations. You could gamify this, show, different teams, how much money they've saved by applying recommendations, all those types of things, okay? And you can schedule these to go out on a weekly basis, daily basis, whatever. That's all part of the capabilities of our dashboarding solution. Okay, 2 more things to talk about here. One of them is auto-stopping. This is a concept of saying, look, in your lower environments, so we're not talking production, but in your lower environments, your QA environment, your dev environment, unless you are a multinational global organization, or you truly have outsourced, follow the sun, there are going to be times in your lower environments and in your Kubernetes clusters where stuff's not actively being used, right? If you're like just a North American dev shop, do everything here, there's probably over 12 hours where everything running in that Kubernetes cluster is sitting there semi-quiesced. No one's interacting with it. So why not be able to stop those workloads? Allow your clusters to shrink, called auto-scaling, back to a minimal set of nodes, and save money that way. Okay, so that's the concept of auto-stopping. Based on an inactivity, we're going to basically take the replica count of a deployment down to 0, but then we also track for any new activity, and as soon as we see it, we bounce the replica count back up. A couple of good things about this, and sort of a little joke here of financial people, please stay awake. What I want people to appreciate here is this is very DevOps friendly. The configuration for this, it's the YAML that we see here. Your developers are going to look at this and say, oh yeah, that makes sense. It's YAML. It's going to be part of your standard deployment process, much like everything else you're deploying. It's doesn't matter what CD tool you're using. You don't have to be using Harness. You could be using Jenkins, Argo, GitHub Actions. Very easy to implement this and include it as part of your pipeline, so that when you deploy Kubernetes workloads, you can set them up to essentially go to sleep if no one's accessing. And then if there's anybody on the call that's a big Terraform shop, we also have a Terraform provider that you can set up these rules with as well. Okay, last slide, then we'll get into the Q&A section. We have a new offering coming out this quarter called Cluster Orchestration. Initially, it's coming out on AWS, but we do plan on rolling it out to GCP, GKE and AKS, so Kubernetes on Google and Azure. But essentially, what it allows you to do is a lot of people don't use Spot today. Because the rug can be pulled away from you. Spot comes with interruptions, right? But it also comes at a highly discounted rate compared to on-demand instances. So the question is, how can we balance the risk of using Spot but get the savings? Okay, and that's what cluster orchestration is trying to address. So what happens here is Harness actually takes care of the compute, so it's auto scaling the node pools essentially, or the cluster. So if the cluster is 99% utilized and someone deploys some new workloads, we'll look at those workloads. We incorporate Carpenter as part of our solution that allows us to select the right node sizes. You can put limits on which node sizes, which families to use, and essentially we'll spin up additional capacity if it's required. You can also, as part of this process, actually define a buffer or reserve capacity. Okay, so you can say, hey, I only want to run 80% efficient because the type of workloads that I'm running and my usage patterns means that I can get these sudden spikes of utilization against my cluster, and I don't want to have to wait for new nodes to be stood up. Like when you ask a cloud vendor, hey, I need another node, it doesn't appear 2 seconds later. Depending on the type of node, the cloud vendor, it could be a couple of minutes before you get that node added to the cluster. So one capability is you can actually define a buffer and keep some excess capacity available so it's there immediately. Now, let's talk about de-risking. So the main thing to know there is, we allow you to choose which workloads do you want to run on those spot instances. Like I mentioned before, a spot instance can go away with 2 minutes notification by AWS, okay? Which means we're going to have to move it back to another node, and there will be a minor interruption. So when you deploy a Kubernetes workload, you usually define how many replicas you want. It's like, I need 5 to support demand, so I'm going to have 5 replicas. You can say, hey, put 1 or 2 on demand, because that de-risks the fact that I should always have 1 or 2. And then those other replicas, let's put them on spot. Let's put them on that low-cost compute. But then we also have additional strategies that you can specify. You can say, hey, but when you put it on spot, spread it out across multiple nodes. So if I lose one node, there's the likelihood of only one instance on that node in the example that I gave. So a lot of different strategies here that we allow you to pick to, like I said, negate that risk of a spot instance being pulled out of the cluster at 2 minutes notice. I know we've covered a lot of ground here. I apologize just from a timing. I'm not going to go in and sort of demo the slides on the optimization slide because I want to make sure that we've got a bit of time here for some Q&A.
Okay. Yeah, excellent. We do have some questions here from the audience. Let's see. First up, we've got a question from Aiden who's asking, how do you handle cost attribution in a multi-tenant Kubernetes cluster where multiple teams or departments are sharing resources?
Excellent. Great question. We'd be doing that via the cost categories that I talked about a little bit before. So essentially, a lot of times when people have a multi-tenant cluster, hopefully they're doing it via namespace. Okay. I mean, it can get pretty messy and detailed if you're not doing it by namespace, but the first approach is by namespace. And so with our cost categories, you can happily write a cost bucket for each of those teams and say, hey, they are responsible for these clusters and these namespaces. Moving on from that, maybe you're tagging that usage. So once again, even with cost categories, not only can we say, hey, include this cluster, this namespace, but you can say, let's include anything with these labels in the cluster as well. So you can cost attribute that way as well. And like I said, worst case scenario, depending on truly how messy your environment is, you can get all the way down to naming individual workloads if you really have to, as part of that cost attribution to those teams.
Okay, excellent. Thanks for the question, Aiden. Hey, we've got another question. You just mentioned tagging. How do you handle tags with inconsistent values such as capitalization or spelling mistakes? That
never occurs. I've never seen that. No. I think tagging's that great question. And people always think, their tagging's not good enough. And to be honest, it probably isn't. I've seen one large multinational top 3 airline in the US that got to 97.3% tagging. That's pretty good for an organization that large, but it took a lot of effort and patience to get them there. Okay. No, I mean, once again, I think any solution has to live with the fact that tagging's not going to be perfect. And that's why I'm not sure if people remember, but in one of my examples on cost categories, I had the example where we, for the production bucket, we were looking for a bunch of different label variations, because it's not only the tag that can be misspelt, but sometimes the value is not consistent. It could be prod in capitals, it could be production, it could be PRD. So just once again, the ability to make sure that the system you're using can account for that, but do it in a painless fashion, as in, let's account for that in one place, one time.
Gotcha. Okay, excellent. A question here from James, who wants to know, what's the weirdest cloud cost optimization tip you've ever come across?
Oh, that'd be time for a funny story where I can't say the customer.
Yeah.
I once worked for one customer, and they were so over provisioned on GCP clusters because they basically they were delivering a new version of their enterprise grade platform, which is the only platform they have, literally like one platform. And they let their dev teams go in and configure all the new clusters. It's like 7 different environments, top to bottom. And we went in there, and they sort of knew that they were not optimized and they were oversized. And over the period of 3 months, we ran all the analytics, we proved all the resizing, and we reduced their GCP bill by 25%. And that was approximately $7 million run rate for the year that we knocked off that GCP bill. So that's about the most unusual situation I've ever walked into.
I'm sure they were happy that you walked in.
They were very happy. I believe they had made sure that their bonuses for the year were based on optimization before we started as well.
Another question here. We have not moved to the cloud yet. Do you support on-premises Kubernetes?
We do. A software vendor never want to say what they don't do, but we don't normally actually cover like legacy data centers and stuff like that. But specifically to Kubernetes, yes, 100% supported. So if you're on-prem today, we got you covered. And as you migrate to the cloud, which may be on your horizon or you're actively doing, we've got you there as well.
Okay. All right. Excellent. Maybe time for one more. We've got a question from Bill who's wondering, how do you evaluate the effectiveness of cost management strategies in Kubernetes environments over time? And what KPIs or metrics do you use to measure success and drive continuous improvement efforts?
Got it. So as a platform, hopefully people have appreciated that we do have detailed metrics, but then we can also roll them up. We do retain all our cost information and metrics for 5 years. So that there's a large pool of data that we can refer back to when we're doing graphs and dashboards and things like that. I tend to find that there are 2 major metrics to look at when you are looking at clusters, though. One is the efficiency score that we talked about, which is somewhat unique to Harness. And then secondly, it's just the overall cost. But you always have to be careful with cost. You have to take it into account with, like units of cost of goods, unit metrics, which is, it is okay if your costs increase, as long as your business revenue is increasing as well, or your usage of the platform, whatever it may be, increases at a higher rate. Okay.
Right.
So we can definitely track cost. You can introduce those metrics in dashboards to sort of say, what is the base measurement of unit and do that comparison to make sure that, unit cost is actually not increasing with costs. But yeah, so I would say, tracking costs as well as efficiency is the goal here.
Okay, excellent. So, Robin, if somebody wants to get started with Harness or find out more, what do you recommend?
Yeah, please reach out to us. More than happy to talk to anyone on the call. We do have a free version, like a little trial instance. So that is available as an option. But it's always good if you want to reach out and just talk to us about what you're looking to do, and we're more than happy to take those calls.
Okay. Well, Robin, Elliot, thank you so much. This was a really informative presentation. Great demos. Really appreciate your insights in the Q&A as well. Appreciate your time today.
Thank you very much, Scott. And thanks everyone on the call.
All right. And as a last piece of business here, we are going to do the Amazon gift card prize drawing for the day. And the winner of the $250 Amazon gift card is Nathan Stearns from Texas. So congratulations to Nathan Stearns. We'll be in touch to get you your card. And with that, on behalf of the Actual Tech Media team, I want to thank Harness for making this event possible, and Robin again for a great presentation. Thanks as always for attending and for your excellent questions. That's going to conclude today's event. Have a fantastic rest of your day.